where we shortcut your learning curve. Today, we're tackling something pretty critical for anyone using agentic AI in software development. It's about that bottleneck, the limited attention span of these models. We're looking at something called Codebase Context Specification, or CCS. So what exactly is this CCS, and, why now?
Yeah, it's a really pragmatic thing, CCS. It kind of came about because, well, we needed it. The core problem, like you said, is that LLMs have this tiny context window. Think maybe a few thousand words tops. It's like trying to grasp a whole novel by, I don't know, reading just one paragraph. It just doesn't work for the big picture. So the AI suggestions, they end up being purely tactical. They just can't reach strategic or architectural levels.
Okay, right. So what's the actual fallout from that? Like day-to-day coding. It sounds like there's a real downside to using these tools without this.
Well, without this. Oh, absolutely. There's a cost. It leads directly to this thing some sources are calling generic pattern disease. Basically, the AI, because it's trained on all this public code, just keeps spitting out textbook solutions, neat, tidy, generic patterns.
And those probably clash with how things are actually built inside a specific company, right? With their own unique setups.
Exactly. They often directly conflict with the organization's established architecture, which means, counterintuitively, the AI can actually lower code quality and consistency in complex projects.
Wow. Okay. That's a big deal. It sounds like the very tool meant to help senior engineers could actually undermine their work on architecture.
Precisely. And that's where CCS comes in. It's essentially a mechanism, a standard way for senior engineers to package up and transfer all that hard-won architectural knowledge to the AI agent. Think of it as a shared language, a protocol, really. So humans and AI agents are on the same page about the codebase's strategic map.
Gotcha. A shared language. So if this is the answer, how does this context actually get, injected? How's it standardized in a project?
It's actually pretty straightforward. The whole idea hinges on a simple convention. A standard directory called .context, right there at the root of your project. That's the spot. Every agent knows to look inside that .context folder first before it does anything else to get the high-level guidance.
Okay, a .context directory. And how do you separate out different kinds of information in there? Because, the story behind the architecture feels very different from technical rules.
Right, and that separation is key. There are basically two main file types doing different jobs. First, you've got index.md. That's a markdown file. It's the narrative entry point for the high-level design, the big decisions, the intent or the why behind the code. Then second, you use files like .context.yaml or maybe .context.json. These hold the structured stuff, the metadata, technical constraints, dependencies, the hard facts, the machine readable.
But code bases are messy. What about huge folders you don't want the AI looking at, like node modules or build artifacts? How do you control the noise?
Good point. Control is built in. You have files like .context_ignore. Works just like .jetignore, basically. Tells the AI what to filter out so it doesn't drown in irrelevant stuff. And there's also .contextDocs. This one's interesting. It helps bridge knowledge from outside the repo, maybe linking to internal wikis or design docs using RAG.
RAG, okay. Retrieval Augmented Generation. So it pulls in wider context, too.
Exactly.
This whole CCS framework,
yeah,
it sounds like it completely changes the developer workflow.
Yeah.
You mentioned something earlier, vibe coding. Without CCS, what does that actually look like? Sounds tiring.
It is tiring. Vibe coding is that constant back and forth. The human is in this tight synchronous loop with the AI, seconds-long cycles. The AI writes a bit, the human course corrects immediately, the AI tries again. It's very hands-on, very reactive.
Right, micromanagement almost.
Yeah.
And with CCS, how does that change?
With CCS, you shift to something genuinely agentic. The human delegates a high-level goal, like refactor this module according to our new pattern, and the agent. It uses the context in the .context directory to autonomously plan, execute, maybe even test, and iterate. It follows the established rules, so the human interaction time. It shifts from those constant seconds-long corrections to more strategic reviews, maybe every few minutes or longer for bigger tasks.
That's a huge difference in the development lifecycle. I can see how for onboarding, say, a new dev could ask the AI, guided by that index.md, for an architectural overview. Better than stale wikis.
Absolutely. Or think about large-scale refactoring. With CCS, the AI can actually perform a proper impact analysis across different services based on the defined context. That's something really hard to do reliably today, even for experienced humans.
So the developer's role changes. It elevates from just implementing code to supervising the strategy, defining the rules of the game.
Exactly. Defining the game rules, that's a great way to put it. You define the context, the constraints, the goals, and you supervise the agent that executes within those rules.
If we zoom out a bit, connecting this to the bigger picture. This sounds like a shift away from the old idea of code as truth, where docs always lag behind. With CCS, it's more like intent is truth. The machine-readable specification becomes the real source of authority.
That's a fascinating implication, isn't it? The specification, the context file, becomes arguably the most critical artifact. It defines what should be.
But does that just shift the burden? Making sure the spec is right? Although, hang on, if that specification is verified and accurate, could a team theoretically just ask an agent, hey, regenerate this Python component in Rust using the exact same verified specification? That seems powerful. Massive potential for change.
It opens up some really interesting possibilities for technical evolution, definitely.
Okay, lots to think about there. So a final thought for you, the listener, to explore. How much of your current work is about defining why the code exists versus just how it exists? And could a structured context spec, like CCS, help you automate more of that how?